but we are still going to do it. So we're going to learn about the last of the theorems today. So we're going to learn about EVT. And this is it. And this is it for the theorems. Even second semester, we don't have any more of the value theorems. So there's three. So you've got IVT, MVT, and EVT. All right, so EVT is going to prove a max and a min. And it's going to specifically prove an absolute max and an absolute min. So let's kind of review over the difference between absolute and relative. Absolute is the very, very highest value and or the very, very lowest value. And so your endpoints can be absolute extrema because an endpoint can be the very, very highest point or the very, very lowest point. Relative extrema are all of the humps. So it has to specifically go increasing to decreasing or decreasing to increasing for it to be relative. So it's got to make that little like hump shape for it to be a relative max or a min. And so because the endpoint doesn't make that hump shape, endpoints are not relative extrema. So today, we're focusing on absolute. So when you're doing your homework and stuff, EVT's lesson is all about absolute extrema, the very highest and the very lowest. Now, when you read your questions, pay attention to the way it's asked, because if it says, what is the extrema? It's asking for the y value. If it asks you for where is there an extrema, it's asking you for the x value. And when in doubt, if you know both x and y, just put them both. They won't count it wrong for putting both of your answers. But what is the extrema is like what it is. It's how high or how low it is. So that's going to be determined by the y. And then where it is, we describe where something is with like it's at x equals blah, blah, blah. Alrighty. So on this graph here, where is the absolute maximum?
C.
At C. Where is the absolute minimum?
D.
D. All right, what about this next one? Where would the absolute maximum be? A. And the minimum?
B.
B. So that one is coming from your endpoints, where the first example was coming from the relative, which are the humps. Do you see the difference?
Yeah.
But both of them could be absolute. Absolute is just the very highest, very lowest. And so then this last example, what's the absolute
C.
max? And then the absolute min?
A.
Yes. Just A. This line is just showing like that's where the point's going to, which is confusing, but... Okay. So at all of these max and mins, the relative ones that have the humps, something special happens with the derivative. So if my graph is going to kind of hump at this point, what is the derivative?
Tangent line.
Yes. What is the slope of the tangent line?
0.
So at the points of all of the maxes and all of the mins,
0.
your tangent line will be 0. What about if my line looked like this? Is this a maximum? Yes. What's the derivative? There isn't one. It's undefined. Why is it undefined?
Because it's scuff.
Yeah. Cusp.
Scuff.
All right. So all of those points are going to be your critical numbers. And so to find your critical numbers, we are going to first find the derivative. And then we are going to set the top of the fraction equal to 0. The top of the fraction is going to account for all of the times when the derivative equals 0, which we figured out was the humps, the max, and the mins. You are also going to set the bottom of the fraction equal to 0. This will account for all of the times when the derivative is undefined, which could be your corners and your cusp, which count as max and mins, but your derivative is undefined. So you got to do the top and the bottom equal to 0, and those are going to give you your critical numbers where something special is happening on the graph. All right, so on example 12, it says find the critical numbers. And the word critical numbers is a vocab word that you need to know means we are going to take the derivative, set it equal to 0, and undefined. So what would the derivative be? Minus 9. And so I'm going to take that derivative, equal it to 0, positive and negative 3. So your critical numbers are positive and negative 3. Take the derivative equal to 0. Is there anything on the bottom on the derivative? Nope. So there's nowhere where the derivative is undefined. So we just have those two numbers. Okay, let's look at 13. 13 is a little bit more complicated. First thing I want to do on 13 is rewrite it So it's not in a fraction. What would my exponent be? Negative 1/2. Yes. Because negative because it's a fraction, 1/2 because it's square root. All right, so I got to take the derivative. G prime of x equals negative 1/2 is going to go in the front. Inside stays the same.
This is chain.
Chain rule. What's the derivative of the x? Or I'm sorry, what's the new exponent going to be? 3/2. When you minus 1, you get the negative 3/2, and then times by
2x.
negative 2x. Okay. It kind of looks gross at this point, so I'm going to clean it up before I start trying to set it equal to 0. So what is negative 1/2 times negative 2?
Negative 1.
1. So I've got x. Right, because the negative 1/2 and the negative 2 turns to 1. The x is still there. That's going to be on top. And then this guy here is going to go on the bottom. Why is it going on bottom?
It's negative.
Yes. All right, 4 minus x squared, and raise it to the 3/2. Okay, so now my derivative looks a whole lot better, and so I'm going to set the top equal to 0 and the bottom equal to 0. When you set the top equal to 0, you get 0. And when you set the bottom equal to 0, you get... All right, so do we care about the 3/2? No. So we're going to go 4 minus x squared equals 0. Add the x squared. Square root.
Plus or minus 2.
Plus or minus 2. All right, so you have 3 critical points. You have 0, positive 2, and negative 2. So all of them are critical points. All right, so how does this apply to the extreme value theorem? Well, the extreme value theorem says that if my function is continuous on a closed interval, then it has an absolute max and absolute min. All right, so the conditions for EVT. Closed, continuity. All right, closed interval and continuity. If that's true, then it has an absolute max and an absolute min. And if you look at these pictures, it kind of shows like this is your starting point and your ending point. And so this would be your absolute maximum, where this guy here would be your absolute minimum. Now, just because it's a closed interval doesn't mean that the endpoints are the absolute max and mins. So this one here starts here and ends here, but the absolute max would be up here at the humps. So the endpoints aren't technically your max and mins, but they could be. We just know that if you're closed on an interval, it has an absolute max and an absolute min. And so even the most simple of functions, like a linear, the difference between open and closed here. The arrows is like an open interval because it's never stopping. So would this guy here with the arrows have an absolute max and an absolute min? No, because this one's going up forever and then down forever, so there's no absolutes. But if you close it off, this point here now becomes the absolute minimum. This point here now becomes the absolute maximum. So that's kind of why EVT works. What's up?
So, like, it's not like the steps, like the other ones where it's like step 1, find if it's like this. It's just more like it is or it isn't.
Yeah, it just exists or it doesn't. It has to be continuous and closed. And if that's true, then they exist. Mm-hmm. All right, so kind of the questions that you'll see on the AP test is more about finding the absolute extrema as opposed to proving that they exist. So when you're finding absolute extrema, the first step is going to be to find all the candidates. And the candidates are going to come from your critical numbers and your endpoints. And what a lot of people forget is the endpoints. But that's the whole point of the EVT theorem, is that the endpoints count as part of your candidates. And then we're going to create a table, and we're going to plug all of our options into the original function. The biggest one will be the max, the smallest one will be the min. All right, so on example 14, it says find the absolute max value and the absolute min value of x cubed minus 3x squared plus 1 on the interval from -1/2 to 4. So I'm saying the word max and min, and I'm saying a closed interval, and that's what's getting me to think EBT. So first step is I got to figure out my candidates. So I'm going to take my derivative, which is
3x squared minus 6x.
We're going to set that equal to 0, and we're going to find our candidates. So what can you take out?
And 3.
A 3 and an x, and I'm left with x minus 2. So my critical numbers are going to be
0 and 2.
0 and 2. Okay, so on my table, I'm going to put 0 and 2. What other numbers are possibilities for my absolute max and my absolute min? -1/2 and 4. Because those are my endpoints. So all of your candidates are your critical numbers and your endpoints, because the endpoints can be your max and your mins. So we're going to take all of these x's and we're going to plug it back into the original function, because I want to figure out what the absolute max and min is of f. So I'm plugging it back into the original. Okay, so when you plug 0 into here, 0 cubed is
0.
minus 0 in plus 1, 1. All right, and then you would plug 2 and -1/2 and 4 in, and you would plug them all in and you would get your y values. I don't want you to worry too much about plugging in the numbers, because that is not a super big part of the test. It's going to be, if you're on the non-calculator portion on the AP test, they'll be easy to plug in. All right, like where you could do it fairly quickly with not a whole lot of work. And if they're really hard to plug in, you would have a calculator that you can just type them in the calculator. Okay, so don't stress about plugging in. And on your homework, if you want to use a calculator to get your y values, so you would plug 2 into f of x and you would get -3. You'd plug -1/2 in, you'd get 1/8. You'd plug 4 in and you'd get 17. All right, so don't worry about the plugging in. It's going to be okay. They're not going to ask you something super outrageous where you're going to have to do a bunch of multiplying and adding. So once you get your table, you're going to look at your table and you're going to determine where the absolute max and the absolute min are. So where would my absolute max be?
Like 17.
Yeah, so 417. And where would the absolute min be?
-3.
Yep, 2, -3. They are. Does that make sense?
Yes.
A lot of times on the AP test, you'll get a point, like on the FRQ, you'll get a point for the derivative or finding your critical numbers. You'll get a point for your candidates, so including your endpoints and making your table, and then you'll get a point for your answer. So even if you get stumped on like the adding and subtracting, you get most of your points from the calculus part. It's like 1 point for plugging in and determining the max and min. Okay, last example, and then I'm done, and then it's like officially Christmas or Thanksgiving break.
Yeah.
What's the derivative?
12x squared 3.
Oh, geez. Yeah, that was crazy. Sorry. 12x cubed minus.
12x squared.
Yes. Okay, and then we're going to set that equal to 0. Take a 12x squared out. And you're left with x minus 1 on the inside.
So x equals 0 and x equals 1.
Yes, x equals 0 and 1. And so on my table, I'm going to put 0 and 1. And -1 and 2. And we're plugging them back into the original because I want the absolute extrema on F. So I'm going to plug them back into F to figure out which one is the very, very highest on F, which one is the very, very lowest on F. So when you plug 0 into F, what do you get? 0. What happens when you plug 1 in?
-1.
-1. What about when you plug -1 in? Close. 7. Because the -1 to the 4th just turns positive, and then the -1 to the 3rd will be negative, which will turn the -4 positive, and it's 3 plus 4.
Right.
And then 2,
Oh, I don't know.
16. 16. 16.
So
So 16 and 2, and then -1.
Yep. So your absolute max is going to be at 216, and the absolute min is going to be at 1, -1. Right, pretty good. So I know the board says matching game. I'm going to do the matching game when we get back from the break. The matching game is over all 3 of the theorems, and so that'll kind of refresh your memory of all the theorems when we come back. So that's the game plan. Did y'all get to the homework? On Thursday?
I
Okay.
set it out.
We'll do the matching game, and we'll do a homework quiz after the matching game when we get back.